Okay, class, we're looking at simultaneous equations and we're going to solve them using the matrix method. Firstly, we have a pair of simultaneous equations, and by pair we mean two. So in this example, we have ax plus by equal to p, we call that equation 1, and cx plus dy equal to q, we call that equation 2. And in an actual question, A, B, C, D, P, and Q will be numbers. So, in order for us to solve them using the matrix method, they first must look like matrices. And we can clearly see that this here does not look like a matrix. So what we're going to do, we're going to rewrite in a matrix form, what they often call the augmented matrix, where AX equal to B. So, what does that mean? A will represent a matrix of the coefficients, X will represent a matrix of the variables, and B will represent a matrix of the constants. And from algebra, we learned that a coefficient is the number before the variable. The variables are the letters that stand alone, and the constants are the numbers that have no variables with them, so they're just numbers. So in this case, the coefficient matrix would be the matrix A, B, C, D. The variable matrix would be the matrix X, Y, and the constants would be P, Q. So this is just a generic form. I'm going to actually do a question, and we're going to see how simple it actually is. So here we have two pairs of simultaneous equations, two examples, 1 and 2. And we're not looking to solve them right now. We just want to rewrite them in the augmented matrix form. So we want to make it look like AX equal to B. And remember, I said that A is the matrix of the coefficients. So in this case, A is the 2 by 2 matrix of the coefficients. We have 2, 3, 1, 1. 2, 3, 1, 1. X is the matrix of the variables. So we have the variables X and Y. And this is equal to the constants 8, 3. And this here is the augmented matrix form. So let's look at example 2. Again, we're going to have a matrix of the coefficients 6, -2, -4, +2. We have the variables now, A, B, and then finally we have the constants 2, 0. And we have written the simultaneous equations in the augmented matrix form, AX equal to B. Thank you. In your OneNote, you will see that I will put a couple questions for you to do, where we are just rewriting the matrix in its augmented, rewriting the equations, sorry, in the augmented matrix form.